Hello and welcome to another video where I'm going to go through Step 2 2021 Question 3. Please, once again, as I always try and remember to say at the start of my videos, have a go at this first. Don't just watch my video before you have a go at it. You have to get a feel for the question. It's much more satisfying for you. It's just a way to do like maths. That's how you get better at maths. You do not get better at maths by reading other people's mathematics. You get better at maths by doing your own mathematics. It's so obvious I think it shouldn't even need to be said, but I'm always quite surprised actually at how many students think they will get cleverer by reading someone else's work. And it's like, reading's good for you? Sure, absolutely. I like reading. I'm an avid reader. I do like reading. But you know, when it comes to mathematics, you have to do mathematics to get better at mathematics. So please have a go. And this one's not a bad question. It really is. And it's typical as well of what they try and do on these extension papers, and Matt does this as well. They introduce you to a new function which they're hoping the vast majority of students, I guess, will be relatively unfamiliar with, or you know, maybe they've seen it once before but relatively unfamiliar with, and then they see what you can do with this new function because you've never been taught how to handle it. It's basically it's tuition. This is what this question feels like. It's a great question though, because I mean, we're just solving equations, an equation with two unknowns and an equation with three unknowns, but we've got these two new interesting functions. Now, I'd seen this one before. This simply just takes the lowest integer, the highest integer beneath the number x. So as it says here, it denotes the largest integer satisfies x is less than or equal to x. E.g., yeah, as they've said here, I think they've given you two examples here. I call it the the floor function. It finds you the nearest integer beneath it. Yeah, 4.2 is also going to be 4. You see what I mean? It just takes the integer part. That's another name for it. Just the integer part of the number. That's all it's doing. And the other function, this curly brackets one, gets the fractional part. So we've got integer part, which is like these brackets, which is standard notation actually for the ceiling, the integer. If you did it the other way around, by the way, you'd be always rounding up. This basically says always round down, that says always round up. But that's for another question. That's not involved here. So as they say, if the squiggly bracket is fractional part, so just to do it on the same two numbers here, fractional part of 4.9 is naturally 0.9, fractional part of 4.2, and sorry I'm not making much effort in the brackets, it's quite common for mathematicians to do that. Yes, I could sit there and make a very nice curly bracket, but in the end we just end up doing squiggles. So yeah, what that does is always take the fractional part. And so as it points out, if you've got integer part plus fractional part, you get the original number. Fractional part is always going to be maybe equal to 0, but strictly less than 1. Integer part is always going to be an integer. Yeah. Oh, and it's interesting how it works with negatives as well. If you've got x is minus 4.2, then because you're always rounding down, minus 4.2, the integer part is going to be minus 5 because you always go down below the number, and the fractional part there is going to be 0.8 because minus 5 plus 0.8 is minus 4.2. So bear in mind, it's more confusing, far less natural with the negatives. Now actually, I don't remember that being a major problem in this question, but let's have a look. First, it just tells us solve these simultaneous equations. Now, I guess the first thing I was thinking was, well, this seems like, let's put it highlighted, a really important fact throughout the question, that x can be described as the integer part plus a fractional part. And remember, when we're solving these equations, we're trying to find what x and y are. So the first thing I did was I added them together, yeah, because integer part plus fractional part is, oh, sorry, using the wrong pen. Integer part plus fractional part is just x, integer part of y plus fractional part of y is just y, and then I can just add these two together. I'm going to get 4.9, 3.9, 3.5. And I sort of looked at that and thought, now I've just got one equation but with two unknowns, so it's not really helped me too much. So that was the first thought which entered my head. And then I thought, maybe I'm just trying to be too clever too quick here, because surely if you've got an integer part and a fractional part here, my fractional part must be the 0.9, as my integer part has to be the 4. Yeah, you know, this is a number between 0 and 1, so this mod x, well, sorry, not mod x, but integer part of x equals 4, I can deduce from that, and the fractional part of y must therefore be 0.9. Yeah, so that's just from looking from that first equation. I can do the same with the second equation, but I've got to bear in mind the negative aspect of this. Yeah, the integer part of y must be -2 here, and therefore the fractional part of x must be 0.6, because -2 plus 0.6 is -1.4. Okay, we can now just write down our answers, because x is therefore going to be 4.6, because it's that one plus that one. And y is going to be -2 plus 0.9, which is -1.1. And sure enough, that equation I wrote down at the start, which I thought would be useful, well, it's really useful to check. Sure enough, that plus that does equal that. And so we've done it, you know. And I just thought that almost seems too easy for a step 2 question. I really did. This is a nice question on the paper. I bet you there's nastier ones than this, because this one seemed really quite nice to me. I wasn't using much advanced maths, and I was using a lot of just like puzzling it out logic in my brain. Okay, now we've got x, y, and z satisfying 3 simultaneous equations in 3 unknowns. Now it's given us a little hint. It said try and show that first, and then hence solve the equations. So, you know, I was kind of like, okay, I do like labelling my equations, and I hope you don't mind, but I'm just going to take another quick picture of them and move them down so I've got a bit more space. So 1 second. I just want those. Copy the clipboard, and let's just put it down here. Or, yeah, let's just work a little bit lower. I'll keep that in mind, that y plus z is 3.2, sorry. Okay, so we've got it there, and I can just see it. So ignore part 3 for the moment, where it gets slightly harder, but actually that's not too bad. I'm trying to show that this is true first. Well, what did I think? I thought, well, I labelled these A, B, and C, just so I know what I'm doing really in my own working, but also so the examiner knows what I'm doing. And first thing I thought was, if I add B to C, then I'm going to get what x plus, okay, and then I'm going to get like the fractional part of y involved. I'm going to get the integer part of z involved. So I did b plus c first. And so b plus c is going to give us x, and actually, yeah, I'm going to write it like that, plus y plus the fractional part of y plus the integer part of z plus z itself, and that's going to equal 10.3. Okay, very good. And then I thought, well, if I can eliminate now x from this, that would be kind of like really quite handy. So what I'm going to do now, as that's b plus c, I'm now going to subtract from it a. So I'm going to use this above equation, but I'm going to take away a from it. Yeah, that's what I'm doing here, because then I can get rid of the x's. That's what I was thinking. So I've got x minus x is nothing, y minus integer part of y, and that's actually fractional part of y, isn't it, if you remember our highlighted result from earlier. So I get y minus fractional part of y plus y minus integer part of y plus fractional part of y, and now I'm going to need to take away plus, let's just write all this down, plus integer part of z plus z minus fractional part of z equals 10.3. Yeah. Now remember, z is just integer part of z plus fractional part of z. So what I can do is have the integer part of z and the fractional parts of z are going to cancel. Just like over here, if I write this as, let's write it real clear, y is equal to integer part plus fractional part. Yeah, and it's the same for z, obviously. Z is fractional part plus integer part. Yeah, and that's what I'm using here, because you just see it real obvious then. We've got fractional part of y plus integer part of y, but minus integer part of y. Oh great, they cancel. And this I did a bit quicker, but I just wanted to show you what's really going on. And then similarly over here, you get integer part of z plus integer part of z plus fractional part of z minus fractional part of z equals 10.3. Almost going off my monitor screen here. Okay, so as you can see, lots of stuff cancels now, and we're left with 2 times fractional part of y plus 2 times integer part of z equals 10.3. Oh, sorry, it doesn't equal 10.3 because I forgot to subtract. I'm suddenly seeing the answer's going to be wrong. So when you do b plus c, that's 10.3. You take away the 3.9 from that, so that's going to be 6.4. And sure enough, we get the result they asked us to derive first. And they're trying to help you solve it here. So we've got fractional part of y plus integer part of z equals 3.2. Cool. And now we can do the trick which we did in the first one. We can just say, okay, well, the integer part of z must be 3, and the fractional part of y must be 0.2. Yeah? That you can see just from this equation. Okay, right. So using that, it's probably best that I actually sort of like think about how this helps me looking back at these equations over here. Well, it helps me a lot because I can start plugging these values in. I can certainly put where we've got fractional integer part of z and, you know, let's just plug them in into all three. We have x plus integer part of y plus fractional part of z equals 3.9. Not much we can do with that. Nothing we've got plugged in. That's a still. Oh, but for b, we've got fractional part of x plus y plus integer part of z, so plus 3, but let's not put that there. Let's just move it straight to the other side and say that that equals 2.3. And then that's what b's become. Similarly with c, we've got integer part of x plus fractional part of y, well that's 0.2, so let's not put this in, let's just put plus z equals 4.8. And that's how c has been simplified. Okay, this looks quite interesting. You know, we can straight away see a couple of other things. We must, I guess, if we've got this integer part of x plus z equals 4.8, bearing in mind we already know z is 3 point something. Yeah, and this is where you need a little bit of thought here. We already know z is a big number, well, quite big, looking at these numbers. Z less than 4, but 3 or bigger. Yeah. Well, that means that the integer part of x must be 1, yeah? Because this is like 3 point something, and after adding the integer part of x, you get 4 point something. That surely means that, I think we can do some Sherlock Holmes here, basically, that the integer part of x must be 1, yeah? Because this is 3 point something. And in fact, you can see that only makes sense if z is 3.8, yeah? It's the only way that could have worked, and that's from the c equation. Now, once you've got that, you can start to deduce a little bit more. We know, for example, now, we know a bit more now, because we can say, okay, well, z squiggle is 0.8, and so a becomes x plus integer part of y is going to be, as that's 0.8, it's going to be 3.1. We already know the integer part of x is 1. We know that the fractional part of y is 0.2. What can we do next? Let's have a look. I'm looking at that. I'm looking at b. I'm just trying to sort of tease out some of the answers now. We can't say here that this must be 0.3 because remember you're dealing with y there, not the integer part of y. We do know now that squiggle z is 0.8. We've got x plus, if we can just look at this one now and this one, we can see, now what do we know? As the integer part of x is going to be 1, I guess, you know, 1 point something, maybe 1.1, then the integer part of y must be 2, yeah? To get to 3.1. It's the only way it can work, really, because we know this can't be 1.7 plus a whole number equals 3.7. So it must be integer part of y is 2, therefore x is 1.1, and we already have the fractional part of y is 2.2, and z is 3.8. We've cracked it. Yeah. It's sort of like a little bit of investigative work at the end there, you know, thinking about the only way it could make sense. It's logic. That's what it really is. Now, did I look at these numbers and plug them back into here? You betcha. Yeah, of course I did. I plugged them back in and checked that they work. I was slightly concerned that there might be more than one solution here, but looking back on my working, there was only one thing, particularly this step, Whereas like, oh yeah, integer part of x plus z is 4.8, but the integer part of z is 3. That only leads to one possible answer for the integer part of x. It means z must be 3.8. Similarly here, where I argued the integer part of y must be 2, that's because we know x is 1 point something, and so the integer part of y must be 2 here to get you to 3.1, and x must be 1.1. It's the only possibilities. And so that's how I've solved that one. Now, let's have a look at part 3. Part 3, quite interesting. Definitely, maybe slightly harder, but not massively different, really. So let's have a work with this. But they've given you some, you know, you've had some training now in solving these, so you kind of feel like, okay, I'm ready for it. Now, the first thing I noticed here, particularly with STEP, where time is a massive problem, even though you get 3 hours, time is a massive problem, isn't it? Look at these two, 3.9, 5.33, 3.9, 5.33. Fractional part of z, integer part of z, same here. The y's have changed, they've all been doubled, but the x's stay the same. Now, surely that means, bearing in mind how we deduced this, that we can go straight to this deduction that we made earlier to get to y plus z is, you know, fractional part of y plus integer part of z is 3.2. Everything's going to work exactly the same there if suddenly your y's are all doubled in the middle. You're going to have exactly the same values popping out. So, you know, maybe I'll do the working again. I'm very happy to do the working again if you like. Yeah, I think I will, just to show you that you're actually going to end up, in the exam though, I wouldn't do this. This would be my advice. I think, basically, as y has been swapped with, all instances of y have been swapped with 2 times that, we're just going to have a 2 in here in our equation. But just to show you it does work like that, even though I wouldn't prove it. I think before I did b plus c minus a, didn't I? This is a, b and c. Well, let's just write down b plus c. We're going to get x plus, and it's actually easier if we don't write, if we write down mod of x plus squiggle of x plus 2y plus 2y squiggled plus integer part of z plus z equals 10.3, and then take away a, we're going to get, okay, once again, mod of x plus squiggle of x minus mod of x squiggle of x, so that they cancel, that's the whole point. Because remember, x is squiggle of x, fractional part of x plus integer part of x. You know, you want to bear that in mind always. So they cancel straight away. Then we're going to get, now it's b plus c minus 2a, isn't it? So 2y plus 2 squiggled y. Oh, that's horrible. I'm annoyed that I'm taking time to do this because, like I say, I just assumed this result was obviously true. But I just want to show you that it genuinely does work out. So now we're going to take away 2y like that, and then we're going to have plus integer part of z plus z minus z squiggle equals 10.3 minus 3.9, which is 6.4. Well, look at this, that cancels. This 2y is 2 integer part of y plus 2 fractional part of y, so we're going to get 4 fractional part of y there. After that cancels with that, and I've dealt with that. And then here, that's integer part of z plus fractional part of z, so that's going to cancel with that, and we're going to have 2 integer part of z equals 6.4. And so guess what? Just as I predicted, 2y squiggle plus integer part of z is 3.2. But don't do that. Try and see the shortcuts. Y has been replaced. You know, all instances of y have been replaced with 2 times that, and so this is just going to be replaced as well, for exactly the same reasons as above. So anyway, if you go straight to this, you'll hopefully realise that this 2 throws a bit of a spanner in the works, because you've only got 2 possibilities now, and we have to work with them separately. It's because there's going to be 2 solutions to this. Yeah, the integer part of z could be 3 again, in which case 2 squiggle y is going to be 0.2, and therefore y squiggle is going to be 0.1. Yeah, and it might be helpful actually, because this is going to lead to exactly the same answers as before, but with y replaced with 2y, if you see what I mean. You've got to be slightly careful in how you do this. I think actually at the time I worked through them all again, but if we take this, we're going to have Z is 3.8 again for the same reasons as before. Let's actually work through. Have I got? I left the. Yeah, I want this clear. Yeah, if that's okay. It's so hard to keep everything on the board when I'm doing these step questions. It takes a lot of algebra. So yeah, what did I do first last time? If we take this first possibility, yeah. Oh, I'll quickly mention the second possibility, and we'll just split the page. Yeah, and I'm going to move this down so I can see it because it's dead handy to have nearby. That's better. Okay, the other possibility, of course, from this is that you could actually have Z is 2, because if there was the integer part of Z, sorry, was 2, then this is going to be 1.2 for 2y squiggle, which leads to y squiggle still being less than 1, taking a value of 0.6, yeah? That's the only way you can do it. You can't have this integer part of Z as 1, because then that's 2.2, and after you halve it, you get squiggle y is 1.1, but that's impossible, because squiggles, fractional parts, are always less than 1. So these are the only two ways of doing it. So what I'm going to do now is just work through again with these exactly as I did before. So I believe before I plugged them in first, so I've got x plus 2 integer part of y plus the squiggle of z. Don't know anything about that. It's 3.9. Can't do much with that at the moment. But the next one, squiggle x plus 2y, and then integer part of z I know, so this is going to be equal to 2.3. And the last one, integer part of x plus 2y squiggle, that's 0.2, so I'm just going to say plus z is 4.8. And then looking at this, I'm going to see as the integer part of z is 3, yeah, this must be kind of like z must be 3.8 again, and integer part of x must be 1, yeah. And you know, really we're just following exactly how we did it before. I'm now going to look at this is like my moderated, well, A is the same, but it's like my modded B and modded C. Now I've worked out this though, I can make A equal to 3.1 and get rid of the Z squiggle, because Z squiggle is clearly 0.8, so let's make this equal to 3.1. That's a 2, isn't it? Okay, so you've got this. Now you know the integer part of x is 1, so this is something like 1 point something, and then 2 times the integer part of y, well, you know, the integer part of y is likely to be 1, that's going to give you 2, and that solves that equation. If the integer part of 2, that's no good, that wouldn't be it. If the integer part was 0, that still wouldn't make sense with this, so the integer part of y must be 2. Sorry, the integer part of y must be 1 to make 2 integer part of y 2, and therefore x equals 1.1. And these are very similar to what was happening before. Z equals 3.8, and now we just need to work out y. As the integer part of y is 1, and the fractional part of y is 0.1, we get y is 1.1. Yeah, and we've done it again. We've got x, z is 3.8, and the other two are 1.1. Once again, check it holds in all three of those equations. I definitely did. Do check all three of those results holds, because it's, you know, just cautious too. Now we've got the other possibility, which is less like the last one, because, you know, when we were solving this before, we got x is 1.1, y is 2.2, z is 3.8. You can see now, you could have just said, well, 2y is that, so this is going to actually be 1.1 in the next one, because you're going to have a 2 times it at the end. But let's work out the next one. Let's just drag this over here so I can see it. It's very hard if you can't see the list of equations. Almost finished now. So this is the only other possibility, I believe, using that fact, 2y squiggle plus z is 3.2. We're going to just use these in the equations again, plug them in, so x plus 2 integer part y plus z squiggle is 3.9, but then we also have x plus 2y, sorry, fractional part of x plus 2y plus 2 is 5.3, so that's going to be equal to 3.3 this time, and integer part of x plus, okay, that's 1.2, so that's going to be plus z is 3.8, yeah? And now if we look at this, knowing that the integer part of z is 2, this means the integer part of x must be 1, and therefore z is 2.8. Lovely, that means we've made some progress. Plugging the 0.8 in here, we get x plus 2 integer part of y is going to be, so 0.8, that's going to be 3.1. And now thinking carefully about this, this means that x must be, y, integer part of y must be 1, x must be 1.1, and y must be 1.6, therefore, looking at the other information we've got there. And once again, you can bet that I checked that all three of those answers worked in that equation, and they do. That's the nicest question I've done on this paper. I've only done the first 3 questions, but personally, I love that question. I thought it was very logical, and I like it when they give me these kind of like, sorry, I've gone up to the other one I've done. These kind of logical questions where I have to apply a new technique they're teaching me. Okay, hope you enjoyed the video, hope you found it useful. All the best, bye-bye.